This is 8.2, Part 1. We're going to look at word problems and how they can look as just a problem with numbers, as an expression, and as an equation. So when we started out this year, we had word problems such as this. Ben is 15 years old, and we had Ben at 15 in our bar model here. And then we would say Caleb is 2 years older than Ben. So we could draw a second bar model, and we had 15 plus 2. And so our equation here would be 15 plus 2, and then we could write equals 17. And then our answer for how old is Caleb would be 17 years old. And we put a box around that. Now, we've been working with expressions lately, and in expressions, we usually have some kind of unknown. And even though we know that Ben is 15, we're going to look at it here as if we don't know that, just for the example. So let's say we didn't tell you what age Ben is. Let's say Ben is X years old. He's an unknown amount. But then we say Caleb is 2 years older than Ben. And so we would still make our bar model just the same as we did above when we had the numbers. We have X in part of it and 2 in the other part. And so we would write Caleb is X plus 2. Now, we can't find out what this equals because we don't know what that variable is. So all we can do is say X plus 2 years old. So that's an expression. An expression is not going to have an equal sign. It's just going to be some kind of a value. Here we have that term of X plus 2 inside parentheses. If we want to make that an equation, we'll look at it a little bit differently. We'll say that Ben is X years old, and we'll say that Caleb, well, we're going to represent him with another variable. We're going to call him Y. So Ben is X and Caleb is Y. So Ben is X years old and Caleb is Y, which equals X plus 2. So that is going to be our equation. We know that Caleb, we're calling him Y, and that Y equals the X plus 2. So we have a couple of words we need to look at. We have independent variable and dependent variable. Independent variable has that IN at the beginning. Independent, or it's dependent. It's not dependent. So independent would be this X by itself. There's nothing else with it. Whatever Ben is, that's going to affect what Caleb is. So that is going to be our independent variable. Our dependent variable is going to be Caleb because that Y equals the independent variable plus 2. So the Y is the dependent variable. That is going to be the variable that is by itself when you have two variables in an equation like this. The independent variable is going to have other numbers with it. Let's take a look at another example. Here is a rhombus. Now a rhombus is kind of like a square, but it doesn't have those 90-degree corners. So it looks kind of like a slanty square. But you can see by my slash marks here that it has equivalent sides. So each side is the same. So if we were going to write an expression for a rhombus, we would think, well, the sides of a rhombus are all the same. So if I want to find a perimeter of the rhombus, if that's my question, what is the perimeter? What's the perimeter of the rhombus? So I would say it's r plus r plus r plus r. Well, that is 4r centimeters. So the perimeter is 4r centimeters. That is the expression. Now the reason it's called as an expression is we have our term here. There's no equal sign. So that's our expression. Now, if we wanted to make that an equation, we could say, well, our perimeter, we're going to represent that as P. We're going to call it P. So now we're going to say P equals that r plus r plus r plus r, or 4r centimeters. So in our equation, we have our independent variable, that's each side, and then we have our dependent variable, which is dependent on our independent variable.